Fine. Your mic isn't working, so we're just going to let this one stay here. Just let it go.
Okay.
You can talk. It'll pick it up.
Okay. Okay, and then the results show that with the data assimilation, the intensity was stronger, closer to reality. So initializing the ocean properly is significantly important for getting the intensity more correct. This work is published in Weather and Forecasting, led by Julie Gaunt. Okay, in terms of Hurricane Maria, we're looking now at different ocean observing systems and how they impact the intensity. With no data assimilation, the dark blue curve shows produced the weakest storm prior to Puerto Rico landfall. When all observations were assimilated, the red curve shows the strongest curve, the intensity was produced. But now we're looking at assimilating individual ocean observing systems, altimetry, Argo, and PHB gliders. And each individual observing system contributed to some extent to the improvement. The PHB gliders are shown at the right, and you can see the light blue curve. You see prior to landfall, we do see some noticeable impact on the intensity due to assimilating the gliders alone. This is averaged over 6 forecast cycles. Looking at this more quantitatively, over these 6 cycles, at 17.6 degrees north, just before landfall, the observed intensity was 140 knots. The unconstrained model and the average intensity was 106.5 knots over these 6 cycles, leading to a significant negative bias. Now, when all observations are assimilated, that negative bias is reduced by 38%. But also, assimilating these 4 components of the observing system, each contributed to that. Altimetry to a lesser extent, Argo, all SST, that's satellite plus in situ, and the PHB gliders. So you see these observing systems working together to give us a better intensity forecast. In terms of Hurricane Michael in the Gulf, on the right you see the tropical cyclone heat potential anomaly during that prior to Michael. This is RTOS minus climatology. The RTOS is the EMC analysis. The much warmer than normal ocean, especially north of about 24.5 north, led to rapid intensification and a realistic forecast when all observations were assimilated. But if you initialize the coupled model with climatology or with an unconstrained model, you did not see that intensification. You need to get the ocean right again. Again, a quantitative look at this. At 29 degrees north, the observed wind speed was 125 knots. The unconstrained model in Visio averaged over 3 cycles was 44 knots less negative bias. And with all observations assimilated, a 77% reduction in this negative bias was achieved. And a lesser part reduction was achieved by assimilating components of the observing system. So we're continuing to work with these observing system experiments, and we're moving into performing observing system simulation experiments.